Hello, good evening. Hello, good evening to all of you. Can you hear me? Yeah, this is my Telegram group. Okay, for my student, you can ask the question in the WhatsApp group. If you are not my student, you also can ask question, but you ask in the Telegram group. Alright, I will look. I will look into the Telegram group. Okay. Now, today I am going to do a bit of revision for you, like maybe like 1 hour. If you don't have question, then I will do 2 hour. Right? If you got question, so I do 1 hour revision and then I use 1 hour to answer your question. You can ask objective, you can ask structural question, and I will tell you my my prediction. Mm. And then tomorrow, same time, I'm going to do it again, right? So today probably I can do fast lah, one chapter. I'm picking the important point to do revision. Okay. So all right. So let's start our revision today. And then got one student asking me in Mandarin. She asked me about this this one, right? In Mandarin. I don't know whether you understand Mandarin or not. She want to do today revision class. She asked me to explain the photoelectric theory calculation. So I will do it later. I will do it later. Because of that chapter, I don't think right it will come out in essay. So I put it at later. Okay, put it later. All right. So let's start. So one of the essay question that I think it will come out is pressure. Right. So pressure, and then you can see here heat lah. So tomorrow I'll give you another two. Right. So after I do pressure, then I'll do heat. All right. So pressure. So we go through what is pressure. Pressure. So what is the definition of pressure? Pressure is force. Normal force. Normal force. Normal mean 90 degree. Normal force act on the unit area. Okay. So pressure is equal to force over area. Okay. So we are not going to do the calculation here. So you need to know what is the application of the pressure in daily life. For example, scissor, knife, right? Here it is sharp, right? Sharp, and then the knife, handsaw, and then when the surface area it is small, right? Contact surface area it is small, so the pressure is high. How will it be? Right, so pressure is equal to force over area. I time the area up to here. Area times pressure is equal to force. So you are using the same force. When the area is big, pressure is small. Right, when area is small, pressure is high. So area and pressure is inversely proportional. You need to know this. So area small, pressure high. Now how about area big? So area big, when the area it is big, pressure will be small. For example, you are going to place a wooden plank, so the wheelbarrow will not sink into the soft ground, right? It will not sink into the soft ground easily. Okay. For example, more tire on the wheel for the heavy truck. So why the tire have to be more? Because it will increase the surface area to reduce the pressure. Okay. Okay, so we quickly go through what is liquid pressure. Liquid pressure, what you need to know is pressure. All right, pressure is equal to rho GH. Remember the unit must be density's unit must be kg m minus 3 so that you can get a Pascal here. You can get a Pascal here. If they don't give the unit like this. For example, waters, the density of water, you know, it is 1000 kg per meter cube. Okay. Now, if they gave you, right, density of water is 1 gram cm minus 3. So you can convert it to here. All right. Make sure you do the conversion. You do the conversion at the side. Okay. How to convert it? So 1 gram cm minus 3 is equal to 1 gram over 1 cm cube. So gram is 1. You want to change it to kg, right? 1 times 10 to the negative 3 kg. Okay. So 1 cm cube is 1 times 10 to the negative 6. So how do you get the negative 6? So C is, the prefix is negative 2. Alright, cm cube. So we put it to here. Right, cm cube. So what you have is, you time it in so that you will get 6. So 1 exponent negative 3 kg divided by 1 times 10 to the negative 6 meter cube. So 1 exponent negative 3 divided by 1 exponent negative 6. You will get 1000. Alright, you can press in the calculator. 1 exponent negative 3 divided by 1 exponent negative 6. You get 1000. Alright. So you can convert it on your own. Alright, you can convert it on your own. So I don't think you need to do that much. So you can just, if you know, you can just convert it into this way on your own. Right, 1 gram cm minus 3, you remember 1000 kg m minus 3 will be okay. Okay, so derive the formula. If you can, you go to learn how to derive the formula. Right. Okay, how to derive the formula? Pressure is how to derive the formula of pressure is equal to rho gh. Okay, so you need to have pressure is equal to force over area. So force is equal to mg. Right, mg over area. You got the first formula. Right, density is equal to mass over volume. So volume of here, it is area of here. Area times the height here. Area times height. Right, mass over volume. So area times height. So area, what is area? Area go up, density go down. So you get mass over density and h. So this is the second formula. So you substitute this A into here. So pressure is mass times gravity divided by m over rho h. So you time it up. So if you don't want to time it up, you should mass mg divided by m rho h. So it's equivalent to mg divided by m rho h. So which is mg time, you tabulate it, right? Rho h over m. Right? You cancel the m, rho g h. Right? I personally like to write rho g h. So you can write h rho g, rho h. It is okay. Right? No problem. So make sure you know how to derive it. Okay. Now, when you deal to this kind of question, so this calculation in essay part, it is 5 marks. So make sure you know how to do it. So sometimes they ask you, what is the water pressure? Right? See properly, water pressure only. So not related to atmospheric pressure. No. So the question will not give you atmospheric pressure. So you just use rho gh. You just use rho GH. If the question asks in meter of water or 10 meter of water. If they ask in Pascal, you must use rho GH. Make sure you know, okay? So for example, I take A. So what is the pressure at here? So pressure here is 10 meter of water. Or you change it to Pascal, rho 1000, density of water 1000, G 9.81, 10 meter. Make sure it is 10. Make sure it is in meter, sorry. What am I saying? Okay, so if the pressure at here, it is rho GH also. Alright, you just substitute in, you will get the answer. So what is the relationship between depth of water and pressure? So pressure is equal to rho GH, right? So the greater the depth, the greater the pressure, right? The deeper the water, the more the pressure, right? Always use the word of greater, right? Always use, right? If you use the more the depth we use more, no, right? So if you get the deeper the water, yeah, right? The more deep the water, okay? But if you use greater, you will always get correct one, right? The greater the depth, the greater the pressure. The higher the pressure, also correct. But if you use greater, sure correct. Alright. If bigger the pressure, also correct. Okay. But I will always suggest you to use greater. Right. Make sure. Alright. So this one I'm not going to do it. Alright. I'm not going to do it. So okay. Now the question like that, exactly the same as what we have done just now. So what we have is find the pressure, not water pressure, pressure. Alright, so pressure here is because of you got atmospheric pressure here, atmospheric pressure here. So they will give you atmospheric pressure how much? Right, they surely give you. Right, so pressure here, pressure at A is atmospheric pressure, PATM, plus pressure of water. Pressure at atmospheric, it is 10. Right, water, it is 10. 10 plus 10, 20. 20. So if you want to change it to Pascal, you use rho GH. Okay. Are you okay with here? Now, I repeat one more time because of it is important. Now, one more time. Here, this question asking you, find the water punya pressure. Water punya pressure only. So the question, normally they will not give you atmospheric pressure. Okay? So you just use 10 meter and then rho GH. But if the question asks you, what is the total pressure or what is the pressure? What is the pressure here? So not because of water only. Here still got atmospheric. Alright, so it is 20. Alright, for example, B, pressure at B, B is 10 plus 20. Altogether is 30. Alright, so change it to Pascal, rho GH, that's all. Okay. If the question it is not giving you in meter, in cm, make sure you convert it. It will be okay. So now this kind of question very, very popular, right? Very popular. So find the maximum pressure at the bottom of them. Alright, so what is the pressure at here? Right, what is pressure at here? Okay, pressure is equal to atmospheric. Right, they never said water pressure. Right, they just ask you what is the pressure, and you need to know how much is this atmospheric pressure. And this question not giving you in meter of water, they give you in Pascal. So you use this one. So this one you have to use water, rho GH, rho GH. So this one is in Pascal, this one is in Pascal, so that you can plus them. If it is not same unit, you cannot plus them. Right? And then they surely ask you, why this one have to be thicker at the bottom, right? To withstand high water pressure. Because of water pressure increase, when the depth of water increase. Right? You need to know. Okay. Now, this is the application of the liquid pressure in our daily life. For example, you can put the tank at the top of the roof there, so the pressure will be increased. Right? So position of intravenous liquid, so you put higher, so the water will flow into the body faster. Right? Dam, same. Dam, construction of dam, so thicker at the best. Right? Why? To withstand high pressure. And the use of the siphon, you need to know how to explain. So this one will give you 4 mark. If they ask you, they surely ask you 4 mark one. Right, in this kind of question. So the siphon here is used to transfer water from higher position here to the lower position here. Okay, so one end it is filled with water to press into the tank at the higher position, and another one it is placed at the lower position. Right, next one, the flow of the water from end of D here. Right, flow of the water from ND produce a lower pressure at here, lower pressure at here, right? Lower pressure at point B, and then atmospheric push the water into the tube A. So this is atmospheric pressure, right? Press the water flow into the tube and then flow out. So this is not so complete lah, this one. So let me explain into detail into you. Actually, before this, I have done one experiment for you for this question, right? So now, let's say this is tube. You fill in with water first. This is all water. So this one, make sure it is at the lower position. So you use your finger to hold it. So this one you put into the pail. All right, so once you let go, this one you let go. All right, so what happened to the water here? The water here will flow down because of gravity. All right, so the water here will flow out. So now here, this one here, it is empty. So we call it as vacuum or partial vacuum. Alright, so partial vacuum mean the pressure inside the tube, it is pressure low. So this one is atmospheric pressure. Atmospheric pressure, if you press lower into it, the lower it is, the higher pressure it is, because this is atmospheric plus liquid pressure. So the water will flow in because inside pressure it is low, so the water will start to flow in and then continue to flow out at the end here. All right, make sure you know how it is function. This is the question. All right, so for I just take one question. For example, so diagram 23 shows the fish is at the depth 2.3 here, 2.3. Make sure when you do the depth it is from the surface of the water, right? 2.3 meter. If they give you like that, all right, it is not depth, right? Make sure you know it is not from here. Must be from the surface of water to the how deep it is. Okay. Now pressure. Now what is the pressure? Right? What is the pressure? And what is the, when they ask what is the pressure, they not asking you what is the atmospheric pressure, right? So now they don't give you atmospheric pressure. So this one they supposed to ask you what is the water pressure, right? Pressure of water. Right, so they should not ask you pressure. If they ask you pressure, they must give you atmospheric pressure. They don't give you. Right, of course you know, teacher, I know the pressure it is 1 times 10 to the power of 6. So no, they don't give you. You just use pressure only. Water. You just leave it at water pressure. So pressure is equal to rho GH. Rho 1050 G 9.81, right? Depth 2.3. After you time it, you will get this. If they give you what they gave you in this question, they gave you, right? Atmospheric pressure is 1 times 10, 1 times 10^6, right, Pascal. So you need to plus PATM here, plus PATM, plus 1 times 10^5, 1 times 10^6 Pascal. So here will be 1, 2, 3, 4, 5, 1.2369 Pascal times 10^6 Pascal. So we don't have it. That's why this question should be water pressure. Okay. So we try. We don't want to try already. So I go for some. For example, the question. This kind of question, many of you don't know how to do. So how to do this kind of question? So water supply is double supply system in a double-story house. What is the water pressure? Water pressure only, no atmospheric, Okay, so you must calculate from the top of the water surface here to the point X. To the point X, it is here to here. So this is 18 plus 2, right? It is total, it is 20, right? So here it is 20 meter, but here it is 9, here it is 9. 9. So here gonna be 11 meter. So pressure is equal to rho GH. Rho is density. Density it is 1000. And then this question you see, they will not give you atmospheric pressure. Alright, so 1000. G it is 9.81. And then H it is 11. So how much it is? Let me press the calculator. So you get 107910, 107910. This is your answer. Alright, this is how we do it. This question is correct. They said water pressure. If they said what is the pressure, so they have to give you atmospheric pressure. Alright. This kind of question also quite important. Right. So now see, this one, the depth it is H it is, what am I doing? H it is less, right? Here H it is more, right? Here H it is even more. So pressure is equal to rho GH. When the H is higher, pressure is higher. Higher pressure, it will spurt out further. Okay, what is the distance of water is affected by what? Right, by depth of water. All right. Okay. They'll ask you this kind of question. Alright, make sure you learn how to do that. Now, for example, explain why the tap of the Ahmad house produce water more faster in the tap of Ali house. Right. So this is Ahmad house. This is Ali house. All right. So now you know this kind of question, it is liquid pressure, you know, right? So the depth of the water Ahmad house, it is higher, right? The depth here, Ali it is 4, here it is 1. So from the top to here it is 4 minus 1, it is 3, right? Ali it is 3. So this one it is from here 10. 10 minus 1. So the surface of water until here it is 9 meter. So the depth of the Ahmad house here it is 9. Right? It is higher compared to the Ali house. Right? Pressure it is higher. So density of these two it is the same. So this one will be higher pressure. So the water flow out faster. Right, this is my answer lah. But anyhow, this one only get 2 marks. So this kind of question I told you, right, for my student, you know, right, this kind of question 4 mark, if you can get 2 mark, then okay already. Okay, so the correct answer will be position of tank higher. The tank is higher of the position of tap. So the second one, it is pressure is directly proportional to depth. Third mark is Ahmad's house, it is higher than the Ali house tank. And then lastly, the water pressure at the Ahmad house, it is higher than the water pressure at Ali house. And then higher pressure, higher velocity. All right, these 5 mark you can get. They will choose the best 4 for you. All right, so we try to have a look into this kind of question. So Ali also want to build a water tank tower, but he has limited area around his house. He decided to install the water tank on his house roof. So now, what kind of tank do you have? Right. So now this one we have done it before. So the here the thickness of the water wall, it is thick. So now thick, we choose thick. Impossible for you to choose thin, right? Thick, not break easily, right? Can withstand high pressure, right? So now size, big or small? So normally it is big. So density, I am not sure. All right. So distance of the water tank and the tap have to be high, right? So the higher pressure. So now density have to be low. So this is what we have done. So the best answer, it is L. Best answer, it is L here. So right, write it. Right. Thicker, why? Can last long, not break easily. Large size of the water tank, can store more water. Low density of water tank, lighter. Distance between the tap, it is longer, further, so higher pressure, L. And then repeat. Make sure, so many times I see you, don't repeat it. Right? Teacher, I write it already. 1, 2, 3, 4, 5, 6, 7, 8 marks. Where is 2 more marks? This 2 mark, it is free. You don't want to take it. Make sure you write it. Calculation, I am not going to do it already. So second one, it is like that, half hour. Yeah. So I try to do fast lah. No choice. Today I think I only can do pressure. All right. So atmospheric pressure, you need to know lah. This is the value. So you can no need to memorize. And then this one, we don't use it. We don't use it. We use these 3 only. We use these 3 only. So now you need to know this one, it is a barometer. This is barometer. And then another one, it is YouTube manometer. This one is YouTube manometer. Okay. This one is barometer. What is the use of barometer? Measure atmospheric pressure. Measure atmospheric pressure. Okay. So now make sure you know this. All right. This one, no matter it is high or low, big or small. So if the atmospheric pressure, it is 76. So if this one is mercury, so it will go up 76. If this one is water, it's supposed to go up 10 meter. Here, 10 meter. All right. So even it is not vertically imaged, so it still give you 76. Okay. Make sure you know. So this one I try to read for you because of it is important. Right. So the diameter of the glass tube will not change the height of the atmospheric pressure. The glass tube, it is not immersed mercury vertically. So the vertical height of the glass still 76, like what I told you. Right. The mercury column only lower. Right. This one will not 76 if the atmospheric pressure decrease. You bring into the higher altitude, like you go at the top of the mountain, so it will reduce, right? Or you got gas inside here. So this one, you can see this one is all vacuum. The one that we are talking about is this all vacuum. If got gas inside, then it will be lower, lesser than 76. Okay, that how to calculate. All right. So, how to calculate? All right. If you got your own way, you use your own way. If you haven't, you forget, you want to use my way, go ahead. Now, find the pressure, atmospheric pressure. So, this one, it is atmospheric pressure, right? This is atmospheric pressure. So, what is the pressure? Here, they are asking you. So, this point and this point, it is the same. So, you just see how much it is. The pressure here, it is 0. Vacuum, 0. So, go down 76. So, 76 cm of mercury. If you want to change it to Pascal, make sure rho G H. H is 76. Why, teacher, you divide 100? Because of this one is cm. You have to divide by 100 to change it to meter. So it is 1 times 10^5. Right? So I take another example with fast. Alright, for example here. Now find the pressure at point A, B, C, D. Right? Pressure at here, 0 Pascal. Pressure at B and C, it is the same, right? It is atmospheric pressure. This one 0, go down 76, so it is 76. Change it to Pascal, like that. Rho GH, right? B and C, it is the same, right? 76 here. So here 76, you go down 20 again, right? So altogether, it is 96. If you want to change it to Pascal, make sure rho GH, rho G, and then H. This is density of mercury. You no need to memorize, they will give you, right? If you can memorize, it will be good also. Okay? Right, rho GH. This one is 0.96. 0.96 from here to here, right? 0.96 because of it is in meter. Okay, make sure you know. This one I don't want to do. This one, make sure you go and read it again. All right. Read it. Effect of the atmospheric pressure at the higher altitude and effect of the pressure at the extreme depth of the extreme depth under the surface of the sea. All right. At high altitude, what will you be? What will it be? Higher altitude, because of when you go higher, the pressure it is lesser. Atmospheric pressure become lower. The percentage of oxygen taken will be lesser. So harder for you to breathe. So increase the rate of breathing because very hard to breathe. Pressure is very low. So you need to breathe very, very hard. So you need to breathe very, very frequently. Increase the rate of breathing. Lower absorption of oxygen into the lung. Increase the metabolic rate. Loss of appetite, dehydration, and inability to think clearly. So make sure you know it. Right? Make sure you know it. It can come out in adjective and structural or essay. So for mountain climber, right, what should you do? Right, so prepare training. So you can prepare the equipments like stopwatch, not stopwatch, but smartwatch. So you can measure the altitude, the pressure, your blood pressure. If you find that your blood pressure decrease or increase significantly, so you must stop and rest. So climb at a slow rate to allow the body to adjust to the change in the pressure. Drink more water, even you are not thirsty. Okay. Now, in the aircraft, what should you do? Increase the pressure at the aircraft cabin to match the sea level pressure. Recycle the air in the cabin so that it is fresh and then contain same pressure as the oxygen level as the sea level. And then drink more water lah. Now this one, very high chance to come out in the application. Very high chance to come out in the 4-mark question. Right? How will it ask? So they'll ask you how do you drink water, for example, here. How do you drink water? So first of all, normally this one no mark, I put it in here because of not enough mark. So same like this. So you are going to suck it, right? So here got a lot of air particle inside the straw. So when you suck it, number of particle inside the straw getting lesser. So pressure getting lesser. The pressure getting lesser, so higher atmospheric pressure, it is going to push it and then enter the straw and then go into your mouth. So where is the format? I am very sure pressure inside the straw low, 1 mark. Higher atmospheric push of water, 1 mark. So other depend on the question, right? Maybe this one because of not enough mark, right? Maybe this one. Okay. Now, plunger, it is the same, right? For example, how it is work. So a particle inside the cup, it is removed when you push it. So the a inside it is removed. A inside is removed. A inside is removed. A particle inside it is lesser. A particle inside it is lesser. So pressure inside it is lesser. Alright. So higher atmospheric pressure push the dirt upward. Format. Vacuum cleaner, suction cup, it is the same one. It is the same explanation. So I am not going to repeat. So make sure you know it. Now, pressure at the very, very low altitude. All right. For example, under the sea level. So the pressure, it is very, very high inside. All right, inside the water there. So water pressure increase when the depth increase. Right. This one you don't need to memorize. Increase of 10 meter cost 1 by 1 atm, because 1 atm is 10 meter of water, if you know. So water pressure and the atmospheric pressure are experienced. What does that mean? Meaning that you are going to experience the atmospheric pressure, and this is water. If you go deeper, this is water. So you are going to experience both water pressure and atmospheric pressure. If you are at the surface of water, you only experience atmospheric pressure. So, effect of the human when the pressure is that high. All right, body tissue absorb excessive nitrogen gas. All right, make sure you memorize it. Okay, so nitrogen gas is dissolved into the blood, and then inability to think clearly, formation of the nitrogen bubble in the tissue of blood vessel if the pressure reduced too rapidly. For divers, so what should you do? Right, what should you do? You can read it on your own. I don't want to repeat. If you cannot see, then I make it bigger so that you can see. Okay, you can read it on your own. What should you do lah? Okay. All right. I simply take one example. For example, diagram 15 shows the two climber climbing Mountain Everest. What will the climber experience when the altitude is higher? Higher altitude, pressure is lower, right? Lower pressure, so very hard for you to breathe. Very hard for you to breathe. So lower absorption of the oxygen in the lung. So increase the breathing, rate of breathing decrease. No, very hard to breathe, so you will breathe faster to get more oxygen. So not decrease, should be increased. Right? Rate of metabolism, it is increased. Right? Not decrease. Right? Hydration, it is dehydration, not hydration. So answer is A. Make sure you know. You see, it can come out in the adjective. Okay. I take one example of here. I just simply choose one. Alright. So, um, given the atmospheric pressure is 76, so what is the height of the mercury column in the H? 76. So here, if no gas it is, this one no gas vacuum, it will be 76. Here got gas. This one supposed to get 76 cm of Hg. 76. But here got 15 pressure of gas, right? Gas is 15. So press it down 15. So 76 minus 15, left 1, 61 cm of Hg. So answer is 61. Okay? So still remember that is two factors that cause the length of the mercury column to be decreased. What is that two? Come on. I am asking you question. Answer me. Answer me. That is two factor cause the decrease of the mercury column. What is that two? Answer question. Answer my question. 开冷气一下。I'm attitude. Yes. One more. One more. Presence of the gas. Like here, just now, where it is, yeah. The mercury column will be shorter, pressure decrease at a higher altitude, and presence of gas. Right? Two, alright. So we quickly go to gas pressure. So this is called YouTube manometer. Unlike barometer, it is measure atmospheric pressure. This one is measure gas pressure. Gas pressure. Okay. So you see here got gas one. Alright. You must see where is the gas. Okay. Now if you haven't used my method, you want to use your own method, you go ahead. If you want to use my method, all right. So always start with where no gas. Here, this is PATM. What is the pressure of the gas? I don't know. Right? What is the atmospheric pressure? They will give you 76. Here it is 76. Go down, increase. So here it is 86. So here same level, and then make sure same liquid, same level, same liquid. So here pressure is 86. I repeat one more time. This is atmospheric pressure here, 76. So at 10, 86. So same level, same pressure. So you have found atmospheric pressure, right? No, atmospheric pressure. You have find gas pressure, 86. So want to change to Pascal? Rho GH. Rho GH. H must be in meter. Make sure. Now the gas is this side, so don't bother about the gas. Start from here. This is 76. 76 here will be 76. This one 76. Here 76. Right, 76. If they gave you 75, you go with 75. Don't use 76. You use 75. Right? 76. Here 76. Go up is decrease. You go up to the mountain, it is decreased, right? 76 minus 8. So here, gas pressure, right? Gas pressure, 68. Want to change it to Pascal? Rho GH. Okay. Again, here, this is the gas. So here it is 76. 76 plus 15. That's all. Alright. So what is the pressure at A? 76. B, same level, same pressure, 76. C, go up, decrease. 76 minus 15. D, here, 76 plus 20. Want to change to Pascal? Rho GH. Alright. So, gas pressure is here. So, gas pressure is C. C. Okay. Make sure you know how. I just afraid this kind of question will come out lah. This kind of question very very long not come out already. Either this one or this one. Alright, make sure you know. So I will take both example. So I am not going to explain into detail already. Right, useless. So now you just need to know how to do it. Right. So this one is rho GH here is equal to rho GH here. Right. Rho GH of water is equal to rho GH of the oil. Okay. Rho GH, rho 1000, water 1000, G 9.81, you can cancel later. Right. H. Right. H here it is 10. Teacher, you said must be in meter. Yeah. For this one, both side compare, you can no need to use meter. You can use cm because this side is meter, this one meter, this one in cm, this one in cm. Okay, but if they ask you convert to Pascal, must make sure it is in meter. Okay, right. Okay, now how about this one? Rho GH, rho GH, right? Rho GH, rho GH, rho 1000, G is 12, G is 9.81, H is this 12. Right? So density of the oil don't know, G, this one is 16. Right? Rho GH is good, rho GH. Make sure you know how to do this kind of question. Okay. So we try to have a look into this kind of question. So here it is a gas, meaning the gas it is from here. Yeah. So don't start from where you got a lot of gas here. So you start from here, no gas. This is PATM. How much is PATM? They will give you 76. 76 go down 15. And then this one go up 5. So meaning you go down until here. You go down 10. 10 cm. So 76 go down, you plus. 76 plus 10, 86. That's all. 86. 86 is gas pressure. Make sure you know how. Crazy, right? We take one more. I take one more. So what methane gas is this here? So this is the gas pressure. They surely ask you what is the pressure of the methane gas, right? What is pressure of the gas? So start from here. How much is pressure here? PATM. How much is this? Teacher, you said 76. So, hey, look at the question first. The question gives 75, you follow 75. They give you 76, you use 76. Don't use your own one, right? They surely give you one. 75 is here. So, 75, go down H plus H. 75 plus H, cm of mercury. They never ask you to change to Pascal. You don't need. If they ask you, you follow. Can I? Almost the same one, so I don't want to repeat. If you got question, you can ask lah. Yeah, I promise you at 30. Ayo, I cannot finish in at 30. If you got any question that about the SPM physics, right? I would prefer your question lah. I will not prefer like you create your own question. Like you create your own question normally sometime like for example you create a teacher how to explain this one, and then there will be like no fixed answer one. So kind of hard for me to that one to explain to you. You create your own one. So I prefer you got the question and then you ask me. Then I'll answer you. You post into the group, post into the Telegram group, post into the my WhatsApp group will be okay. 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 This kind of question you know lah. Let me see. Okay, let's say I do one question. So name the apparatus of Q. Q is YouTube manometer, right? Now calculate the pressure Pascal in 3.1. 3.1. Pressure is they said in Pascal, so 30 cm of mercury. 30 cm of mercury. And first thing, what is the pressure? Teacher, you said here it is atmospheric. Yeah, I did say. But you see, this one is tutup. Tutup means no gas here. This is vacuum. No gas at here. No gas at here. So this is called vacuum, 0. Here it is not atmospheric pressure. This is 0. Here it is 0. 0 plus 30. So here it is 30. So here going to be 30. Pressure of the gas is 30. Change it to Pascal. That's all. Okay? Change it to Pascal. That's all. Right? So 3.2. Here it is not 0. This one is tutup. Right? This is cross. This one is not vacuum. Right? This is atmospheric. Atmospheric, how much? They said 1 times 10 power 5. They don't give you 76, so you cannot do anything. So pressure of the gas is, here is PATM plus 18. PATM is they give you is 1 times 10 power 5. In SPM, I want you to write 1.0. Right? Now, no, not now. Just write 1. Follow. They 1.0. Teacher, 1.0 is nothing. Right? It is not important. No. Just follow. Right? Pascal. And then this one, it is not. You cannot plus. Pascal. And then this one, CMH, you cannot. So make sure you use rho GH. Convert it first. Rho density. Go and find the density for mercury, 13600. G 9.81. H it is 18, 0.18. And then you plus them, you get the answer here. I am not doing it. So atmospheric plus 18, atmospheric 1 times 10 power 5, rho GH. And then you get this. Make sure you know. Okay, make sure you know. Now, what will happen to the different height of mercury when the apparatus 3.1 brought to the top of mountain? Now, top of the mountain, when you top of the mountain, 3.1 you bring up, no change. Why? Because top of the mountain, number of the particle is lesser, but you cannot hit here. It is not related. But 3.2, you bring up to the top of the mountain, number of the particle at the top of the mountain lesser. Pressure decrease. Pressure decrease. So you press lesser. So this one, meaning the gas will be higher. Gas is stronger. So it will go up higher. This one, no change. This one will go up higher. Okay? 3.2 will go up higher. But they ask 3.1. 3.1 no change. 3.2 go up higher. Alright? Okay. Okay. Now let me tell you my prediction. So this year, what I predict, it is like, I think Pascal will come out. I don't know. I predict pressure will come out this year in essay. But the one that I want to predict here, it is Pascal. So Pascal, you better focus. You focus into Pascal lah. If you don't want to read others, or you read Pascal. So hopefully you read everything in pressure lah. So Pascal principle, you need to know the definition. Make sure you learn how to write it. Alright, make sure you learn how to write it. So Pascal principle said that the pressure applied to the enclosed fluid, it is transmitted uniformly into all directions of the fluid. So now F1 over A1 is F2 over A2. Mean F1 over A1 is pressure here. F2 over A2 is the pressure here. Pressure here and here inside the liquid will be the same. All the same. Okay. And we take easy example. F1 over A1. So this one, because of it is both sides equal, so this one 20 cm. Okay. Right, teacher, no need to change. No need. But if the question asks you what is the pressure at here, so you need to change. Pressure is this force over area. Right? Force it is 10, area is 20. Because of cm times 2, so cm times 2 is -4. So you need to know. Right? It is 5 times 10, bro. 4 Pascal, I think, or 3. I'm not sure. Press calculator. 10 divided by 20 exponent -4. 5,000. Sorry, it is 3. Okay. E. Okay. Make sure you know. But if they don't ask you, so you just F1 over A1 is equal to F2 over A2. F1 over A1, F2 over A2, you will get the answer. Right? Make sure you know how to calculate, because this one will give you free mark. And then sometimes they'll ask you multiplying factor. So you need to know what is a multiplying factor. Multiplying factor 10 Newton become 20 Newton. So multiplying factor, it is 2. All the area, it is like times 2. This is called multiplying factor. Okay. Now you need to know larger the piston, larger piston here, so larger the upward force. The pressure, it is the same. Pressure 10 over 20, 10 over 20. Right? So the pressure, it is the same. Teacher, this one getting bigger. Pressure still the same as this one. But the multiplying factor, it is bigger. Why? Because we call this one as slab piston. This one is called master piston. Master piston smaller, higher pressure. Right? Slab piston bigger, larger the upward force. You need to know. Do I need to repeat? Because later we are going to see in more detail. Right? Okay. This one, if you want Mandarin, you can have a screenshot. Right? Save it. Right? Screenshot. Right? Smaller master piston. This one Mandarin. Smaller master piston, pressure bigger. Alright, so the force produced will be bigger. So slab piston bigger, so the pressure remain the same, but the force produced will be bigger. Do I need to see this one? One example need lah. Alright. So now calculate the pressure at here. Right, pressure is force over area. Right, force over area. Force over area. Area is 10 times 10 to the -4. Make sure you know. Right. So how much you will get? 20,000 Pascal. So now second one, they will ask you what is the pressure at here. Here inside, it is the same. Pressure at the larger piston, it will be the same. Because Pascal said the pressure will be equally transmitted throughout the fluid. Okay, and cross, make sure it is encrossed. So upward force, right? You can use F1 over A1, F2 over A2 if you want. You don't want, you just use this one. So I try to use F1 over A1, F2 over A2, F1 over A1, F2 over A2, F over 50, F over 50 is equal to 20 over 10. Cancel the 10, 5 times 2, 5 times 2, 10. You still got one more zero, 100 Newton. Yeah, if you are using this, you'll get back to the same thing. All right. Application, you need to know. Memorize it. All right. So, toothpaste. All right. Applying pressure to the tube of the toothpaste. It is Pascal. So, this one hydraulic jack and hydraulic jack, hydraulic brake. Yeah, you need to memorize how it is work. Go and read it. I think I need to explain. But never mind. I explain. So when you press the brake pedal, right? So the pressure is exerted to the brake fluid. The brake fluid is inside here, inside here, inside here. The brake fluid inside here, everywhere here. So transmitted uniformly to the from the master piston. This is called master piston, the smaller piston, to the slab piston. Where is the slab piston? Slab piston, it is here, here, and here, and here, and here, and here. Right? Slab piston. So this one will move the slab piston forward and force the brake pedal, brake pads against the disc or drum attached to the wheel to slow down and stop the car. Right? This is called hydraulic brake. Hydraulic brake. When they ask in format, you need to separate it to tell lah. All right, which one have to be big, which one have to be small. Right, piston have to be small, slab piston have to be big. Right, to produce a higher pressure. So this one hydraulic jack, same thing. Right, same thing. Right, same thing. So you can try to have a screenshot and then read it. Right, make sure you know how to write it. This is called smaller piston. This one we call it master piston. So here it is a bigger piston here. This one bigger piston here. This is called slab piston. Slab. Slab have to do work one. Slab. Master and slab. You need to know master and slab. Master piston or master cylinder will be okay lah. Same thing. Alright. I don't think I need. This question I need. Wait. Okay. State the principle that explain the operation of the hydraulic jack. So this is called Pascal principle. Compare the pressure at X and Y. X and Y, it is the same, equal or same. Calculate the pressure. Pressure is force over area. So do I have force? 100. Smaller piston. Smaller is this one. 100 divided by 0.05. So you get 2,000. Right? So calculate the force exerted. Pressure equals to force over area. Pressure is 2,000. We have just calculated it. Force over area. Area for the larger one, it is 0.08. You time it up, then you get 160. Okay. Now, how much is the multiplying factor? Here you apply 100 into it, and then this one, the force output is 160. So how much is the multiplying factor? Not necessary to be whole number, but mostly it is they give whole number lah. How much is the multiplying factor? How much is the multiplying factor? How much is the multiplying factor? Come on. No one? Hello? Easy leh. 100 to 160, it is 1.6, right? Multiplying factor is 1.6. No one answering me. Okay. Now, based on the figure, explain one modification to the smaller piston to enable the lift to lift up the heavier load, right? Reduce the size of the master cylinder, right? Or master piston. Make it smaller, right? Smaller, pressure higher. Okay? Smaller, pressure will be higher, right? Now, second one, explain why the hydraulic jet become less efficient when the oil of the oil content of air bubble, because of air bubble can be compressed. So you need more force to compress the air bubble. This kind of question you need to know. Now, how to lower down the larger piston, right? Open the release valve. Here it is a release valve. Okay. Make sure you go and learn Pascal, I try to see essay question lah. Essay question. Objective we do quite many already. Okay. Now this kind of question format. Now 9.1 shows a hydraulic jet. Okay. Explain the working principle of hydraulic jet. So now force apply into here. Now force apply into here to the smaller piston. So there is a pressure produced. So pressure produced. Pressure. First one is force applied. Second one is pressure produced. Third one is pressure is equally transmitted to the enclosed fluid. And then the fourth mark it is the large force will be produced because of the pressure it is equal. Okay. Now you see how the mark given. So the force applied, I got the first mark. Pressure, yeah, you got the second mark. So pressure uniformly transmitted, yeah, third mark. And then force 2, it is output, maybe I don't have, so I get 3 mark. Alright, this question you can get 2 mark, then okay already. Make sure you know how to write it. Okay. Okay, we try to have a look into this kind of question. Hydraulic jack. Like that. We rest for a while. We rest for like 10 minutes. And you try to do this question. I'll show you the answer later. So you try. I don't want to mark for you. No need to pass it up to me. Just do it on your own. Spend your time to try to do. And then if you got other question, you can start to post into the group or personally to me if you know me, or into the Telegram group. You ask in the Telegram group. If you are not my student, you post in the Telegram group. Okay, you got not necessarily this kind of question lah. Like you can have like other chapter. If you don't know, you want me to answer. If I know how to answer that, I'll answer you. All right. So I give you 10 minutes to rest. So We will be right back. And then if you don't have other question, you just do this question. We are going to discuss later. All right? Okay, I'll see you later. I'm back. Okay. All right. Can we discuss? Add minutes only. Still got 2 more minutes. All right. So we discuss, okay? 9 minutes. Okay. So now oil. Sorry. Type of the hydraulic fluid must be oil. Okay. So boiling point will be high. So area of the input piston small. Output big. So the best is P. All right. Best is P. So we see the answer. All right. Oil. Why oil? So it will not producing a bubble. But recently I see not producing a bubble. They don't really like it. So you can choose to write one more, which is it will not producing a bubble, or oil cannot be compressed. Oil cannot be compressed. Water will produce a bubble, right? When it boil, when it hot, it will produce a bubble, right? So water still can be compressed a little bit. So oil cannot be compressed, right? So now high boiling point, not boil easily. Not turn to gas easily, not evaporate easily also can. Small input piston, like what I told you just now. Large pressure. So large output piston produce more force, output force. So P, it is the best one. Repeat. You mark on your own. Right? If you don't know, right, you try to do revision into this one. Right? Try to do more into this one. So this one, I think it is important. All right, let's go ahead. On this question, I didn't do. Many lah. All right. Now you got any other question that you want to ask? You can ask into the group. Like what I told you. You can ask in the group or PM me in WhatsApp if you know me, or Telegram group. Okay. So Archimedes. Archimedes said that the buoyant force act to the no, not this one. Wait, where is my Archimedes principle? Archimedes principle said that when the object is partially or fully immersed into a fluid, it will experience a buoyant force equal to the weight of the fluid displaced. Right? So buoyant force formula is rho Vg. This one, if you can understand, go ahead. But if you still don't understand, then leave it. Okay. Now, make sure you know, there will be a few kind of question, like sometimes they'll give you two different mass, right? So the mass is different, so the weight will be different. The weight is two. I use gravity as 10, so 2000. So this one is 1000. So your buoyant force is equals to the weight. So that it can float. So this one is buoyant force is equals to 1000. So this buoyant force is more than this buoyant force. Weight of the board, A more than B. So volume of the water displaced, A more than B. Right? So buoyant force, A more than B. Right? So type of the liquid, type of the fluid, same. Both. If this one is seawater, this one also seawater. Right? But there will be another kind of question. Like sometimes they'll ask you, one is river, one it is seawater. Okay? Now, what is the weight? 1000. What is the weight? So how much is the buoyant force to make it float? 1000. How much is the buoyant force? 1000. Okay? So the weight of the A and B, it is the same. So water displaced, this one more, this one less. Okay? Volume A displaced more than B. So buoyant force A and B, same. Right? Density of the fluid, river water, it is higher. River water, it is smaller. Right? Sea water got salt. Right? Higher. Density of seawater more than river water. So for this case, is buoyant force is equal to rho Vg. Right? Buoyant force, it is the same. The higher the density seawater, the less the volume displaced. The lesser the volume displaced. Okay. Now for this question is these two buoyant force not same. Buoyant force is equal to rho Vg. Alright. The more the volume displaced, the more the buoyant force. More the volume displaced, the more the buoyant force. Alright. Why? Because the density, both are the same. Density is equal. You need to see which density different. Which is the density same or not? The buoyant force same or not? Alright. When you answer the question, make sure you know. Okay. Make sure you know. So Archimedes, I don't think you come out because your paper 3 already do the same thing. Right? Already do buoyant force. So I predict pressure, but I'll predict Pascal. So this one you agak-agak need to know lah. So you need to know weight. A buoyant force is equal to weight minus apparent weight. What is weight? So when you hang it without putting it into the water, so this is called weight, 0.65. So this is called apparent weight. Weight is you put into the water. So weight minus apparent weight, it is your buoyant force. Okay. Now, this kind of question, you need to be very, very careful. All right. This one is gram cm minus 3. Right, 400 gram. Right, 1.5. So when they ask you about the buoyant force, all right, so you need to change it. But this question, no, they don't ask you. Right? So they don't ask you. So now they ask you what is the volume displaced. So object density is emerge fully. Emerge fully mean the whole thing is go in. Right? So density is equal to mass over volume. So this density is equal to mass over volume. Right? Density of the object is 20. All right, 20 put in, mass 400 put in, volume I don't know. Right? Volume I found it is 20 cm cube. So 20 cm cube. You put it in, so this volume displaced. Volume displaced will be same as the volume of the ball. But if it is partially immersed, then it will be other story. Because of this one 20 go in, it is not fully go in. So this one is less than 20 cm. Right? It will less than if it is floating. Right? Or they call it as partially immersed. weight of the liquid displaced, right? Weight of the liquid displaced, it is, you got the volume here, right? Density is going to mass over volume. But this one is free. You cannot use 20 already. You use 1.5. 1.5 is mass over volume. Volume is 20. So you time it up, it is 30 gram. Right, gram. So you want to change it to kg also can. But if you not, you leave it as 30 gram will be okay. Right? Next one. So buoyant force. Buoyant force is equals to the rho buoyant force is equals to rho Vg, right? But in this case, buoyant force, right? Buoyant force is equals to the weight of the water displaced. Right? Weight of the water displaced is m times g. M 30 gram. I change it to 1000. Right? I change it to kg. Divide by 1000. Right? G 9.81. So I get this. Now, of course, buoyant force is equal to rho Vg. Now, the rho, you have to be very, very, very careful. Rho, which one? 20 is rho density. Or this one, 1.5. So, must be 1.5. Rho must be density of the fluid, not density of the object. Be very, very careful. Density is 1.5. Gram, gram cm minus 3. I told you, time 1000. V, volume, it is 20. Time 10 to the negative 6. G is 9.81. G is 9.81. Right? (1.5) exponent negative 3 times 20 exponent negative 6 times 9.81. So it is, wait. 1.5 exponent 3, not negative 3, I'm sorry, times 20 exponent negative 6 times 9.81. So you get 2.943. You can use this, can. You can use this, can. No problem. Right? Okay. All right. Now, so let's see one question. Now, this kind of question, when the question asked, many students will get it wrongly here. Right? So now, when you leave it here, right, you don't immerse into the water, the pendulum bob, it is not go into the water. So this one is heavy. This one is heavy. The reading of the spring valence, it is high. Right? So, but once you start to go in, so now that is a weight. Let's say this is 20 Newton. Now you lower down, so that is the weight of the water displaced, right? Here, some water displaced. So when water displaced, mean there is a buoyant force. So buoyant force supported. So this one will less, this one will less than 20. Maybe become 18. But if you lower it down further, right? So this one go in a little bit, this one go in more. So you find it, this one, the more the ball go in, the more the water displaced. The more the water displaced, the higher the buoyant force, right? So more buoyant force pushes upward. So this reading become from 20, become 18, become maybe 15. And then after it is fully go in, the water displaced here will be remain the same already. So because there is no more space for the pendulum bob to occupy. So the reading will be 20, 18, 16, 15, 20, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5. Okay, like that. So it will be flattened. Right? So this kind of question, you need to know how to answer. Now, I takut it come out into this way. See, no, Wait. Give me 1 minute. Okay. Now, electronics balance. Right? They put one electronic balance. I don't write well electronic balance. So now this one it is 500 gram. This one 500 gram. So the water itself 500 gram. So at first it is 500 gram. Now you lower it down. When you lower it down, mean this one is 500 plus some more. Right? Maybe 10 gram. So this one will 510. So from 500, here 500, become 510. And then if you lower down more, so the reading will be more. The balance reading will be more. Not this not this spring balance. It is electronic balance. So 500, 510, 520, 530, and if you fully go in, so it will not increase anymore. So the graph will look like this. Okay? Make sure you know. Make sure you know. So this one is called the reading of the spring balance. So if we got the electronic balance, then it will be answer like that. Okay. All right. So this one I don't focus into it. It is from your textbook. Application you need to know lah. Application. So Archimedes principle, submarine, submarine or this one, what is that called? Working principle of the ballast tank in the submarine. You need to read, right? Although I don't think you come out. Okay, hydrometer, right? You need to know hydrometer, how it is work. Hot air balloon, how it is work. Okay. The shipping, the ship and the Primsol line, right? This one, Archimedes. So you need to go and read on your own. Okay. Now Archimedes done. All right. So this is end of the revision here. All right. That is many question lah. Any other question that you want to ask me? If not, then I go to this chapter. Because of you are asking me, Cikgu, can we do revision on that one? Quantum physics calculation. You want me to do a bit of this one? So I don't think this one will come out in essay, but structural can come out. Normally structural question when they come out, it is not that hard one. So you want me to do revision? Wait, let me see which part photoelectric effect, the calculation. This one, the one that you want me to discuss. This one, the calculation. Okay, is it this one? This one, So I'll do a bit. First of all, you need to know E is equal to HF. E is equal to HF. And then you need to know what is F. F is frequency. So V is equal to F lambda. F is equal to V over lambda. V over lambda. So H, this one you substitute in is V over lambda. So you get H E is equal to HV over lambda. HV over lambda. Okay, can be this way. Now second one is photon energy. Photon energy is W. Right, W is work function plus kinetic energy. Right, maximum kinetic energy, half mv square. Okay, now so okay, now half mv square is equal to hf minus w, right? So because of this one, you bring it to here, right? This one you bring it to here, become minus hf minus w, minus w. So what is work function? So we call this f naught, f naught. So you substitute back into here, substitute, because of you want to find the threshold frequency, right? You want to know how much is threshold frequency. Threshold frequency, we call this f naught lah, right? So now the kinetic energy will be 0 because of that time when you shone the light into the metal. So the electron will be not emitted yet, about to emitted. All right. So now hf minus hf naught. Kinetic energy is hf minus hf naught. So if you factorize it, you will get this formula. And if not mistaken, this one it is given. This one it is, and then this one it is given in SPM. So, but the one that the first one, this one given, but the one that with lambda one, it is not given. So you need to derive on your own. Okay, you need to derive it on your own. Calculation. Is it this one the one that you want? Okay, we try to have some example. Okay, a blue light with the frequency this one, right, shone on the clean calcium metal surface. What is the maximum kinetic energy? So you know that you got this formula, right? So hf minus w. W is work function. You put it in, then you get the answer. Right? If the question don't have, right? Like the question like this. Okay. Now, what is the maximum velocity? Now they are asking velocity, so kinetic energy. So we got E is equal to hf minus w. Because of this one, velocity already. Velocity is related to kinetic energy. So half mv square is equal to hf. F is c over lambda minus w. Just now I have derived it for you already. Now half mv square is equal to this one. The problem is they are giving the hc over lambda. You try to have a look into here. hc is this one. hc 1.243 times 10 power 3. All right, but this one is ev. So 1 electron is 1.6 times 10 to the negative 19. They don't give you directly c over lambda everything, no. Right, they put it in all together, hc already. Okay, and now a nanometer. So nano, this one already in nano. So what do you put in is this one is 550 here only. You no need to time 10 to the negative 9 because already in nano. Right, lambda minus w. Okay, so you get the answer, velocity. You time it up, you will get the velocity. Am I too fast? Are you okay? Okay, not. See why I said this kind of question you no need to focus into. This kind of question you no need to focus into. Now I want to ask you, where to ask you? Objective maybe can, but objective so hard. If they will give so hard question. Now first thing, I don't think so. Second one is if essay, so 5 mark question, so it will come out this kind of question. You do so many times, you know, right? So you will not. So essay, I don't think it will come out this kind of not calculation. I mean, the question. The question. Let's say it come out in question number 9. Question number 9. 4 mark one. What you want to ask? So hard to ask. So you don't need to focus into this one. You know what I mean? Don't focus into this one that detail. So you just need to know the formula will be okay. Wait. For example, okay, you see in no, not this one. Wait. Wait. Simply choose one. Okay, let's see. This is the one that they gave you, right? HF is equal to W plus half mv squared. So you want to move this one, then minus W. HF, you know, work function, it is a minimum, right? Minimum energy needed. So then you got that formula. This one. You substitute in, so you H F minus F naught. That's all. You know what I mean? So you don't focus into this one. So I don't think they will come up very hard question for you. Okay? But anyhow, we try to see this kind of question because of you are asking. So when the photocell is shown on the red light of the wavelength 750 nano. Yeah. Remember this year, when you due to this kind of question, if they really ask you, so you need to write it out 750 times 10 to the negative 9 meter. So the lambda rate, you need to write it out times 10 to the negative 9. So this one 7.5 times 10. This one move 2 decimal, so this one become negative 7. Okay, you need to write it out on your own. I told you already. Make sure you know. Okay. Blue light 460, and then maximum kinetic energy emitted by the blue light is 2 times of the red one. Okay, 2 times the red one. So what is the work function of the photoelectric material in the photocell? So E is equal to HF minus W. So only this kind of question when it is related to work function, only this formula. So H you put it in, F you don't have, right? It is C over lambda. C over lambda. Right? This one is the red one. Lambda is times 10 to the negative 9 minus W. So you get this. Now the second one is the blue one. The blue one. E is HF minus W. But the blue one, it is 2 times of the red one. 2 times of this one. Put it in. Right? H C over lambda. Lambda is 460 nano times 10 to the negative 9 minus W. So you play with the answer thing and then you get the answer. Next one. Threshold frequency. So W is HF. This one it is given in the question, in the formula list. You don't need to worry about this one. Okay, so you can get the answer. Is this the one that you want? What is EV? We need to multiply 1.6 times 10 to the negative 9. Negative, You don't really know the concept. Okay. What actually? Concept actually. Okay. Oh, you don't know what is EV, right? Okay. EV is called electron volt. Okay. Now, normal way that we use is like normal like At least today you run how many kilometer? You run. Let's say you are running. So you will burn how much of calorie, right? You use that calorie, right? But in physics, we all use joule. We all use joule. But this one is electron volt. Electron volt is another unit of joule, but it is not in joule because an electron is very, very, very small. All right. So we know that the formula is W is V potential difference is equals to work done to carry a unit of charge, right? This one you know. Voltage is equals to potential difference is work done to carry a unit of charge, right? You know, okay. Now, what kind of charge do you have right now because of electron? So, V is equals to electron. V is equals to EV. This V is voltage. You understand what I'm saying here? Work done, this is energy, right? EV. So, how many EV? 5 EV, 20 EV, 15 EV. Easy to say, right? How many electron volt? 20 electron volt. But actually, how much joule it is? It is like 1.325 times 10 to the negative 20 joule. So hard to use, right? So I take this example for you that you can understand it better, I guess. Wait, cathode ray oscilloscope. Still remember? Oh no. Seldom ask in EV. If they don't say anything, we use in joule. Let me find for you. No worry. Electronic. Okay. For example, cathode ray. Okay. Let's say we got this kind of question. Let me see. Cathode ray. Kinetic energy of the cathode ray. If not mistaken, I give some example into this one. I forgot where already. Like that. Okay. Like that. Energy is equal to EV. Okay. Now, for example, now a cathode ray producing electron of this one. Alright. Find the energy. Energy is equal to EV. Alright. So energy is 10. No. E. E is 1.6 times 10 to the negative 15. V is 10,000. So you get the answer 1.6 times 10 to the negative. This one is 19. Sorry, 19. So you get negative 15 joule. Alright. But now, calculate the energy in terms of EV. Alright. E is equals to EV. E is 1 electron. 1. V 10. It is how many? 10,000 EV. Do you get what I mean? 10,000 EV equal to how much? This much. So what is the thing that we are using? We are normally using this one. We are normally using joule. We don't use calorie. If you ask me calorie, I tidak pandai. I tell you, I don't know. Right? Like that one is imperial unit. Imperial unit. We don't use imperial unit. Right? So this one, they can ask you 1000 EV, how much? So you just sub E in will be okay. You get what I mean? You get what I mean? Okay. I don't know whether you really understand it or not. For example, like Uh, this question they give in EV, 1 EV, 1 electron volt, 1 EV, 1 watt, E you substitute in 1 EV is this much, right? 1 electron volt is 1.6 times 10 to the negative 19. You don't need to focus into this one. That's why I said, they seldom ask you in EV. But they can ask you. They can ask you. They can ask you. Electron volt. That one is called electron volt. Alright. Now, any other question? You can ask your question. I still got 10 minutes for you. You got any other question that you want to ask? You pause it, and then I will answer you. Ask question. If you don't ask, tomorrow is the last day. Tomorrow 7:30, I will do the same thing again. You prepare your question. So if you got question, you can pause it first. Tomorrow I'll answer you live. You pause it to me, teacher. You help me to explain this one. I will explain it to you. Like some of the question into I cannot like. No, I don't want to explain previously you asked this kind of question. How am I going to answer? I cannot answer. I can answer you like question. The answer is B. That if how to explain? Cannot explain. I need to explain in real life. Okay, you are asking question. Okay, so this one the one. Wait. Okay. Okay, so we answer this kind of question. When a photon material is shown on the blue light wavelength is this one, with this one is emitted, what is the threshold wavelength? Okay. HE is this one. Okay. So the formula is E is equals to HF minus W. Okay. E, what is the threshold? HC over lambda minus W. Okay. Threshold. So E is equals to HC over lambda. W is equals to HF naught. So they want to find threshold wavelength. So they want to find HC over lambda minus HC over lambda naught. Are you okay until here? Should be okay. Now I'm going to substitute in 1 photon. Wait is 1 photon? 1 photon with this one. So the energy is 0.75. Electron volt, electron volt is times 10 to the power of negative, times 1.6 times 10 to the negative 19. Okay, electron volt. Okay, Hc. Now this one is called. Oh wait. No need. I no need to change. This one I no need to change. Why? Because this one Hc is given as electron volt nanometer. So I don't need to change. So 0.75 Hc over lambda. Hc is this much. 1.243 times 10 to the 3 over lambda. Lambda is 452 nanometer. Because of this one in nanometer, so you don't need 452. Alright, minus Hc 1.243 times 10 to the 3 over lambda naught. Okay. I write off first. If not, I got not enough space. Okay. Now, factorize the same thing out. 0.75, 1.243. Oh, no need lah. You just bring this one to here. Okay, you just bring this one to here. So, what do we have? Wait, let me write off some first. If not, so it is so annoying. Here, 0.75, 0.75. This one come to here. No. This one come to here. I rewrite. This whole thing come to here, become positive. 1.243 times 10 over 3 over lambda is equals to this one, 1.243 times 10 over 3 over 452. This one come to here, become minus 0.75. Okay, so I settle this one first. 1.243 exponent 3 divided by 452 minus 0.75 is this one, 2. So this one go up, 2 go down, right? So 2 go down inverse time this one, 1.243 exponent 3 is your answer. 2486. 2486. Don't have? Wait, one more time. 1.243. 1.243, correct? 1.243. 0.75 here, correct? A photon, yeah. This one, 0.75. 1.243 times 10 over 3 over 452, correct? What is the threshold wavelength? Threshold wavelength. Head C, correct what? Over lambda naught. This one move to here, become positive. This one move to here, minus. I press one more time. 1.243 exponent 3 divided by 452 equal minus 0.75. Yeah, 2. Here it is 2. 2 go down. This one lambda go up. Mean this one divided by 2. 1.243 exponent 3 divided by 2. 621.5. I press wrong. 625.1.5 nanometer. Answer is B. Answer is B. Correct or not? Answer is B. This one is nano, in nano already. This one is in nano already. Because of this one is given in nano, EV. Nano. So you no need to times 10 and negative 9. Answer is B, correct? I pressed wrong just now. Press wrong. Press too fast. Should press 2 times. In SPM, you need to press few times. If you cannot get the answer, you press few times. 600. And then, I tell you lah, this kind of question, if I tembak, I also tembak A or B only. Because the wavelength of red one, the red one, it is about 650. 650. The blue one, it is about 450 nano. So either this one or this one only. Cannot be 1000 something. 1000 something. This one meter, no chance. No, what kind of. This one is not the wavelength of the red color. No. So this one is too big already. So either this one or this one. Blue one is about 400 to 600. Any other question before I end the class? Like what I told you just now, I haven't finished. Give me 5 more minutes. I'm lost. So. Like previously, you asked me this kind of question. No, I don't want to answer you. I cannot. Without video, I cannot answer you. Like now, you're asking me this kind of question. Like which circuit will make the bulb light up? Okay. So here, positive, negative, light come into here, it can come into here. This one reverse bias cannot. So out. So come to here. Okay, can. So I use other color, like if this one positive, this one negative, how? Oh, here cannot, here cannot. This one out. So how about this one? Cannot down, it go down to here. Finish. Right, I change other color. From here, start, come to here. Okay, so both can. So this one is correct. Like what I told you before, if you want to memorize, you see these two parallel or not? These two parallel or not? If both are parallel, okay, and then they are not facing each other. If you follow my class, you know. So this one not parallel, okay, salah. This one go up, this one go down, salah. This one go up, up, down, down. They are not facing each other, okay, betul. Up, up. This one up, one down, cannot. This one up, this one down, cannot. No choice. Only this one. Okay. Any other question before I end the class? So tomorrow I will do revision for you. I can do heat only lah. So pressure. Now the one that I predict is pressure, heat, electric and electronic one. I will prefer electronic. I think it is electronic. So essay question. So you focus into these three will be okay. Electric or electronic, because both electric and electronic 2 years not coming up. All right. Okay. So I am going to end here. Tomorrow we are going to continue 7:30. I'll send into the group again. So if you are not subscribed my channel yet, you subscribe. Or if you got brother or sister or friend want to join tuition next year, I am giving free tuition from Form 4, Form 5 student, February and March. Free one. So ask your friend to subscribe me, or join me. Okay, contact me. So okay, I'm gonna stop here. If you got brother or sister want to join tuition for free one next year, so look into me. Okay, I'm gonna stop here. I'll see you again. Okay, bye bye. Good night. Good night. Bye bye.